Today we're going to talk about using similar triangles to help solve some problems. So the first thing we want to kind of pay attention to is that when two angles in one triangle are congruent to two angles in another triangle, the third angles are congruent and the triangles are similar. The symbol for similar is the little squiggly sign. So hopefully that statement makes some sense. If two angles in one triangle are the same as two angles in the other triangle, and we both have 180 degrees in each of the triangles, then I hope that we understand that that means there's only a certain number of degrees left, and it has to be the same for both, since we have the same number of angles that have been used up so far. So let's look at a few examples. So here we have whether these are similar triangles or not. Well, looking at number 1, might be a little bit easier to see on this one, but if I look at my corresponding angles, the angle here, 50, corresponds to the angle there on the second triangle. The angle 75 corresponds to this angle 75. Well, by definition, since two of the angles are the same in each of the triangles, that would mean that x must equal or be congruent to the y angle. So yes, these two are similar. We'll try to make that a little bit neater. So yes. Now looking at the second one. Well, in this case, we don't really have this easily things to match up. But another way that I can solve this is if I focus on each of these triangles separately. We know that if I add my angles together, I should add up to 180 degrees, which we've learned from a previous section. If I solve this problem, I will find that x equals 63 degrees. So that means this is now 63. If I come over to my little triangle, I have 63 plus 63 plus y equals 180, which makes y equaling to 54 degrees. So that means here is 54. Well, then it's pretty obvious at this point, I think, that this angle would match with that angle. This angle matches with this angle. So now we can say for sure, but while we're already here, this matches with this one. So again, yes, these two triangles are also similar. So for these next two, we're going to let you try them, and then we'll come back to work on them together. So pause the video, give these two a chance to decide whether these are similar or not, and then come back on and hit play, and we will go through them together. So let's first look at number 3. Well, if we do the same idea and find the missing angle of each triangle, we should hopefully notice that the missing angle on the left side triangle is 48 degrees. The missing angle on the right side is 52. Now that does not tell us that they are not congruent. However, if I do look at the corresponding angles, 52 would correspond with 42, and those are not the same. Certainly the 90 corresponds with the 90, so that one's fine, but I also need another one to correspond, and the 38 degrees does not correspond with the 48. So because down below the corresponding angles are not congruent, then we would say that these are not similar. So looking at the next two triangles, we again would solve the two triangles for the missing angle and then compare their corresponding angles. Well, when I solve the top one, I find that the x equals 24 degrees. When I solve the bottom one, the y equals 66 degrees. Again, 24 is not 66, but when we focus on the corresponding angles, this angle and this angle, which correspond, are equal. Certainly, we know that the right angles are equal, and we also would have these two corresponding angles, and they are equal. So in this case, we would say that these two are similar. Indirect measurement uses similar figures to find a measurement that is difficult to find directly. What that basically means is that we can use similar figures, similar triangles in a lot of cases, to help find measurements of things that we can't measure. For example, if I wanted to find the measurement of a building, I could use some shadows to create some smaller triangles to help find the height or estimate the height of the bigger shape that I can't actually measure. So indirect measurement is trying to find measurements of things, or at least estimate of measurements of things, that I can't just go ahead and measure really easily. So how am I going to use indirect measurement? Well, here's an example. We are planning to cross a river, and we want to know how far it is to the other side. You take measurements on our side of the river and make the drawing shown. Well, first we need to know, why is ABC and DEC similar? Well, we got to look at a couple of things here. If I bring this picture into the view here, we just talked about how we know that they are similar if there are two angles or corresponding angles that are congruent. That would mean the third one is also congruent, which makes the two triangles similar. Well, hopefully we can agree that because angle B and angle E are both right angles, they are congruent. So there's our first set. And we know they're congruent because they are right angles. Now, if I look at my drawing, we have two angles that are across from each other that are created by intersecting lines. Well, these two angles are also congruent, and they are congruent because of vertical angles. Which we talked about in the last few sections with the parallel lines. So what are these two angles? Well, here's a case where we don't want to name our angles just angle C, because really there's four angles, angle C, that go all the way around that vertex point. So here's a case where we have to use the three vertex method. So the first one is going to be angle BCA. I start at the 90-degree angle, I go to the C, and then I go back out to the A. So then that, we are saying, is congruent to angle ECD. Again, notice how the C vertex, which is the one that we are claiming is the angle we want, is in the middle. And we also want to make sure we are doing the same orientation from the 90-degree angle vertex to the one we want, and then back out. So there's an example right there that because there are two pairs, that is why those would be similar. So now we want to talk about B. What is the distance across the river? Well, from the picture, we can see that the bottom piece, which is across the river, side ED, is right now using the variable x. Well, what do we know about these two triangles? Well, we were just told that these two triangles are similar. So triangle ABC is similar to triangle DEC. And what do we know about similar figures? Well, we know that they have the same shape, meaning the corresponding angles that go together are the same. But here we don't really care so much now about the angles, we're more concerned about the distance or the side measurements. What do we know about the sides? Well, similar figures have sides that are in proportion to each other. And the key word there is proportion. So, with that information, what I want to do is make a proportion of two equal ratios to solve for the missing x. So here's what I'm going to use, and obviously there's a couple other ways you could make this proportion. I am going to use the proportion of 50 compared to 40, which again would be me referring to this first triangle as 1, this bottom triangle as 2. Then I'm going to say the next one that goes together is the 60 with the x. And again, you could have a couple of different types of proportions that still could be the same and still could be give us the same answer. It's important that you make sure that you have the correct ratio of one triangle to the other triangle and that you go in the same order on each ratio. But at this point, now I just have to follow my cross products. Well, if I do my cross products, I am going to get 50x equals 2400. When I divide by 50, I will then get my final answer of 48, and we always want to make sure that we have the label that is correct. We are dealing in feet. So the distance across the river is 48 feet. So this section is more about how we actually use some of the things that we've been learning in this chapter. This is the last section of the chapter, so hopefully we will start piecing together a lot of things and help us figure out with some problem solving ideas, and we should be ready to really use this information to help us going forward with different applications.